In this video, I'm going to talk a little bit about how we use the AVO VCM 163, how we test tubes and how we set it up and all that kind of stuff. If you want to know about its hardware and how it looks inside and all that kind of things, please look in my previous video. I'll put a link to it in the description. But let's get to it. Now you have seen the other video and know exactly about all the hardware. So I can go straight to using the tube tester. And in this video, I'm only going to test ECC81, also called 1287. I got one here, and this one is known to be good, and I got another one that is known to be bad. So we can try and set this up. First, we need to configure the pinouts. So what we got right here, that will be the pins, the tube pins. It is actually also written up here, valve pin selector. So that will be, this is the valve pins and not those numbers. So valve pin here is probably written closer to the feature number. This number here is only used so we can look up in the manual how to do the configurations, and we can dial through a lot of different configurations for pin 1. Cathode, heater, the negative side of the heater, well, this is AC, remember? Heater, the other side of AC, so that is positive. Well, again, this is AC, so that is a little bit funny. And this is the grid, and this is the other grid, and so forward. So, but since we can't remember all the pinouts of this particular tube in our head, and we actually don't need that because we can just look up in the manual. So here is my little bit tired manual, and everything here is just written so it is starts with 1 and la 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 all the way, and here we should see ECC81, and what we do is, this is the VCM 163, the one that we got, and so that will be the settings, the recommended settings directly from the manual. 851.228.413, and then the rest, the 0, that means unconnected. And then we don't need to look at any of that. Here we go with some of the settings for all the different voltages. Filament 6.3 volt. This is the voltage for the grid, so that is 2 volts. Voltage for anode is 250, and of course we don't have this is for pentones, we don't need that. Anode current is 10 milliamps, and then this is the amplification factor called GM, or milliamp per volt, and we should expect to see 5.5. So all those settings we need to dial in. So I think I've done it right. I double checked this carefully. 851.228.413. Okay, so far so good. And all we have to remember from the settings, that is the B9A, or also called the no volt socket. Fantastic, we need to remember that. I can actually just plug in my good tube, so that is fine. Our grid voltage is 2 volts, 0.23, so that is that one. We don't have the screen used in this one because it's a triode. So anode voltage is 250, and here is our AC heater voltage, and that is 6.3. And here is actually something that I don't see explained that much in other videos, how to use the good bad indicator. So the idea is the nominal value of a GM, remember that was 5.5, and this is exactly how it is set here. Nominal value 5.5 to that little arrow. You're not supposed to read down here in this area at all. This is just for configuring this dial. So that means from now on you could hire a half-blind monkey to test your tubes, and all they have to do is see, is it green or is it red, and put it in 2 different boxes, and then come back 1,000 tubes later, right? Or you could also write down all the different values and do it really nice and carefully selecting whatever you're doing. And that is why a lot of people don't like to use this and just call it a useless gimmick. But here is actually how it's supposed to be used. That is to set here, and then you just see if it's over or under here. The idea is that 5.5 is the perfect value, and 50% less than that, you see, should be around here, right? Then you should throw away the tube. And this is just only on gain. But how about its nominal current? So we know that according to the setup from the manual, it was 10 milliamps, but some of them are actually a little bit more than 10 milliamps. So I put this for 30, and then I expect about here. So that is 10. So I think I've set up everything correctly here for my gain measurement and current measurement. I am in the first anode, checking cold, and then we could power up the unit. So since just like I explained in the previous video, since everything here is unregulated, all the voltages, that's tappings on the transformers. So that means, of course, you need to have a very accurate mains input, or you just dial this for the calibration point. That's 2 ways to do it. I got a variable mains connected to this unit, so I can just adjust for exactly 230, and then it will read the center point of that one. See, there's a tiny little line down there. As you see here, it is exactly over that. So this is my calibration or check for my mains input is correct. So there's also another thing, because this one is stimulating the grid with an oscillator, and there's an amplifier that detects the anode, the AC on the anode, and display this on the meter. So to check for correct oscillator and amplifier levels, we could just turn this one into calibration. And what we should see is this one going to exactly to cal, and it is a little bit low. So how we're going to calibrate that is we can pull out this one and then adjust the gain setting, and that means we're going to read out the correct gain. I just know this one is a little bit low because I really don't want to bother poking around with this. That just means my readings, they're gonna be a little bit on the low side, so who cares? This is 0 point nothing, right? So let's go back 0 to 6, and then 5.5 should be a perfect value, right? So we are now in check cold. That is what this means, check cold. And in cold mode, with a tube connected, I can now check for leaks. So as you see now, I have a short to the heater, and that's of course because the heater is connected to 0 volts because it's cold. So that's why I will have a short here, right? So now I check cathode for leak, no problem, and then I can carry on with all the different combinations of everything in my tube and check for leaks, and there should be no leaks as we see here, and then I'm back to input supply voltage. Fantastic. Now I can heat up the tube and let's see if there is any light in it. Of course this is a little bit unfair with all that light here. I also recommend looking at the warm up of, or the light up of the filaments. If you see a really shiny bright blink or something like that, it could be a reveal that you have a bad designed filament, and that could cause you short lifetime of your tubes. In most tube designs you will have a series resistor that will slow start the filaments, so it shouldn't be a problem with the poorly designed filaments if your design is made correctly. But as you see here, we see both of the filaments light up. Remember, we are running in parallel mode. See, 2 here, right? On pin 4 and pin 5. Those are connected in parallel. And we are running in at 6.3 volts. So the two halves, or the two filaments, they're in parallel. So that means it is possible with this setup to see only one filament. Okay? That is just what you need to be aware of. Now, when it's hot, we can see if there is a good isolation between cathode and heater. And again, we should see absolutely nothing. And then we go to test. Now it will inject a very, very weak AC signal into the grid. And it will measure the AC on the anode, and it will display the gain factor. Remember, 5.5 was perfect, and we are actually reading a little bit lower than we should. So that means this is very, very close to perfect values. And also we are reading a little bit more than 10 milliamps, and that is also normal because 10 is nominal, but I normally see them a little bit more than that. And yeah, that is my 2 volts, my grid volts, so that is perfectly fine. And this is, of course, one of the 2 diodes. So now we can switch over and measure the other one. And see, current is a little bit lower, and so is gain. So let's switch back. See, a little bit higher gain and a little bit higher current. And this is quite normal to see a little bit difference in your 2 triodes. I mean, it's really, really difficult or rare, super rare to see both of them track perfectly. You will see a difference about this. I mean, if you're lucky, you will see that little, really. So this is my gain test. There's also the gas test, and in gas test mode it is measuring the current in the grid. There's of course not supposed to be a current in the grid. Under those test conditions it's going to be very, very low, and of course you don't see anything here on the meter, so that tells us again this tube is good. So I think we're quite happy about this tube. Let's try another one. So you can, of course, pull and plug tubes in cold, because in this setting I don't think there's anything bad going to happen. And also, what you should also be very, very careful about with a tester like this, when you heat it up or when you play around with your tubes and stuff, if you see the overload crank it off immediately, or even just flip the mains switch, because you don't want to break the meters or break any of the diodes and transistors and stuff inside. So it's not a funny thing to repair this unit. So now I already know that we don't have any leakage problems with this one. And go hot, and again we see a really nice warm-up sequence. No shiny bright blinks or anything bad, so that is really good, a good sign. But this tube also look a lot older. It's more dark and stuff like that. So yes, it is definitely old, and this is why I saved it just for this demonstration. Oops, I can go back here, it doesn't really matter. So we don't have any leaks between cathode heater, so all that is perfectly fine. And let's go test. And what do you know? Very low gain, and of course very low current. Remember, this is 10 milliamps 5, so it's only like 2 milliamps of current. So that is of course why we don't have any gain, and that is in one half of the tube. Let's try the other half. So that one got just barely. Well, this is about half of what it's supposed to be, and what is that, 7 milliamps? So this is of course also really bad, and you should just throw this tube away. There's no, there's not. Also, what I wanted to tell you, when you're testing tubes like this, especially dual triodes or any dual tubes with, of course, they got 2 filaments, and those 2 filaments, they are normally connected in series. I actually made a nice little drawing here to show you why this is smart. So this is what the manual says that we can do. This is our ECC81, and that will be the pins, and that will be the numbers of the features. We're actually only interested in pin 4 and 5 and 9 features. That is the heater, and that is the center point of the heater, because here is how it looks like with the pinout. And this is what the manual recommends. But can you imagine if you're testing 100 tubes? You're wasting a lot of time on all the tubes with a broken filament. What if it's this one that is working, and you are probably on that part of the tube and that is working, so you're poking around and measuring around, and oh, it looks super duper nice, and 2 minutes later you go to the other tube. Oops, that is completely dead because there's no filament, there's no heating in this filament, so you're wasting all your time. So the trick is, of course, you want to go in series mode, so you want to heat them up with 12.6 volts. So all you have to do is change the 2 settings here. So pin 4 and pin 5 now got 12.6 volts, and nothing is connected on pin 9. So we put this to 0, so that is not connected, right? And this is what my father always did. I'll show you a picture from his lab. This is exactly what he did. And the reason why he's doing this is he's testing a very high number of tubes. And we can zoom in on the top of the settings, and we can see that the settings is definitely set for 12.6 volts. And also what he did when he's testing a lot of tubes. he's using paper like this to write down all the values, very, very carefully numbering. So this is tubes from 1 to 25, for example. This is the where you write the whatever kind of tube it is, right? And your settings and all your measurements. And he's putting in all the tubes in foam, and the foam is now numbered, and then he can match all the tubes and use them for his products. See, here is a handwritten note about some of the most normal tubes that he's using, and here you see the two different settings for the ECC series, that you can of course have it for 6.3 volts or 12.6 depending on those settings. And this is not covered by the manual. You need to figure this out yourselves, and of course it is much smarter to have them in series. And it was the ECC81 that we're using, and then you can of course use this settings, and then exactly as we talked about, the 2 volts and the 10 and the 5.5, right? You also got, I wanted to show you typical characteristics that is from the manual. And what else did I find in all these? Yeah, here we go. I think that was see, we got ECC81s. So he's going for this range to that range. He's going from this milliamps to this milliamps. Oh, and he's testing at 200 instead, but he's going for a little bit lower voltage. So that is interesting. But those are the settings that he's using to test for his products. Typical settings for his products, huh? But now, when I got all these things, that means I'll be able to repair some of his products, because I can test for the exact settings. So let's try the 12.6 volt setting. So I think we did this right. The 2, 3 here and the 0 here, right? So we turned this on, and this is again the same half dead tube, and we didn't see any difference at all. Let's go back to test and see what is going on. I believe we're going to see the same boring values. Yep, of course it hits exactly the same. So when you have low emission, you got low emission for a reason, right? So something is probably wrong with the tube. So what happens if we overvolt this very, very old and crappy tube? So let's actually just double this voltage and see if we can blow it up, right? See, now it's going to light up really, really nice and shiny, and we're going to burn away all the bad materials. And what we're waiting for here is the gain to stabilize a little bit. At the moment it just goes up and up and up, and that is because you're still burning away bad material. See, it still goes up a little bit. And if you wait a little bit, then it's going to stop doing that when it's done being regenerated. But what we can do is we are in a hurry here. We don't want to bore you with all this annoying waiting time, because I actually wanted to show you what you can do in a short matter of time. Remember, this tube was completely dead. It was 50% under nominal gain, and the correct gain is 5.5. And also remember the values from the previous tube that was perfectly new, and now it's almost good, and we didn't even do this for what, like 10 seconds. And current here is actually nominal. Let's see the other one, if we were able to restore that one. No, not at all. But that is probably not possible with that one. We could try and give it a lot more and see if it comes. See, it likes a little more heat, and with a little bit more heat you get more emission. And so we could of course just leave it here for an hour and see if it's good, because remember, we were about to throw this tube out. And let's see if we'll get anything out of that one. And of course it's a little bit fun to try and restore really bad tubes and see if they kind of go back to good. So that was the, I mean, really? I think we should sell this tube really fast now before somebody figures out what we did. Yeah, but I don't recommend you do this, by the way. Of course you should not sell crappy tubes or try to restore stuff, but if this was the last tube you had on stock and you wanted to perform some sort of an experiment, yeah, you could probably do this. I will save this tube for a few weeks and a month and see if it's continuing to be good. Well, that is a little bit of fun with tube restoring as well. And sometimes I'm lucky about this, lucky with this restoring, but on some tubes they really don't do this. But this one, yeah, seems to be good. So that was quite funny. I think that was more or less what I wanted to show you about how to use this the AVO tester. I hope you had a little bit of fun, and please come again soon.